Hi there, I'm Elaine. I'm going to talk about binary and hex. Let's go back to primary school for a moment. Remember writing down hundreds, tens and units, HTU? Well, that's what this is. 100 is 10 to the power of 2, 10 is 10 to the power of 1, and 1 is 10 to the power of 0. So in base 10, you write the 10 and then you write the power next to it, starting from 0 to 1 to 2 to 3. So 10 to the power of 3 is 10 times 10 times 10, which is 1000. That's the next level up. So taking this exact same approach, you do the same with each base. So binary is base 2, so you write 2, the base, like you've written 10 there, write 2, and then you put 0 to the power of 0 to the power of 1 to the power of 2, and so on. And that's how you work out binary. When you're first learning, it's always good to write it out. So you have 1, 2, 4, 8, 16, 32, and it goes up in 2, so 2 times. With base 10, you have 0 to 9. With base 2, you have 0 to 1. You only have 2 values that you can use. So in the case of this example, we're using the ASCII table here, which I obtained from ASCIItable.com. And I'm having a look at values that can be entered via the keyboard or other methods. So for example, the bell is decimal 7. So that's 7 units, no tens, no hundreds. In terms of base 2, it's 1 unit, 1 2, and 1 2 times 2. That makes 7. So 4 plus 2 plus 7. So in binary, a bell is all the ones, whereas in decimal it's 007. Another example, the tab, that's decimal 9. Again, you just need 9 units. If it was 10, then you'd have to set this to 1 and that to 0. In binary, again, we need something to represent a 9, so we need 8. This one's no good because that's 4, and the highest value we could have with 3 digits is 7, so we needed to have the fourth place. So that's your 2 to the power of 3. That gives us 8. 2 times 2 times 2 is 8. So 8 plus 1 is 9, and that's how we get our binary. So binary for a tab is 1001, whereas it's 009 for the decimal equivalent. Octal is the same in that you represent the base here and then you put to the power of 0, 1, 2, 3, etc. And in the case of octal you have 0 to 7. In the case of decimal you have 0 to 9. So the equivalent of a capital H, where it's 72, 7 tens, 2 units. In terms of the 8s, you have 164 because 8 times 8 is 64, and 1 8. That makes 72. So that's octal. So going back to binary, I'm not completing hello, but this is the start of hello. H, go back to your ASCII table, you see H is 72, so you need to represent a 72 with your 8 bits, which is what is used for the ASCII table. The first 7 are used for the main characters, and then you have the extended ASCII table as well, extended character set. So for a H it's 64 plus 8, which is 72, and that's it. So this is the binary for a capital H. If you look at the lowercase h, you'll see that's 104, so that's a different character altogether represented on the computer. That's why you need to make sure you check for both, and that's also why you have case sensitivity on Unix and Linux and Mac and Raspberry Pi. Lowercase e, you can see that is 101, so 64 plus 32 is 96, plus 4 is 101, so that's the representation for lowercase e. And then for an L you have another representation which is 108, so again 96, 102, 106. Did I get that right? 108 we need here. 96, 104, sorry, 108. My maths failed me for a few seconds. So have a go at this and see what you come up with. You can pause it and have a think and make make some notes. Okay, the answer is welcome. So hopefully you got that. So binary calculations, hope you've understood now that you use these values to add up like you do with hundreds, tens and units. So this ASCII character here in the extended ASCII code set, which is 181, is represented in this way. So it's 10110101. Another example. So everything's represented as binary in a computer, so even IP addresses. So the 192, the 168, the 10 and the 12. What would they be? So what's 192? It's going to need the 128, but it can't use the 64. 128 plus 64 would make what? Or can it? Actually can. It's 11000000. So that's 192. 168. This is the one I was looking at when I said that. It's 128. You cannot use the 64 for that one. 32. 128 plus 32. 160. And then 8. So that'll be 10101000. 10. 00001 010. 12 0000 1100. That's how that will be represented. So permissions on Linux, Unix, Raspberry Pi and Mac, they're set up in blocks like this: owner, group and world, or all. User group all, they're the other names used to refer to it. So example file 1 has read, write x, read and read. So execute, the ability to write and the ability to read, whereas anyone in the group can only read it and everybody else can only read the file, whereas the owner and the user can read it, write to it and execute it, run it. So what you do to set those is you add all the bits if they're all set, and that equals 7. 1, 2, 4. In this case only that bit's set, so it's 4 plus 0 plus 0 because they're not set. Same for this. So chmod is the command used in Linux and Unix and Raspberry Pi and Mac to set permissions. So chmod 744 is what this comes out as, file 1. You can do this in your head eventually, it's so straightforward. You just do the 1, 2, 4, add them up. If the bits are set, or if they're not, you exclude them. So have a go at these. You might want to pause it for a moment and just have a little think about it. But I have the answers here, just in case you needed to have a cheat. So you might encounter base 16 more so than octal, and that's used for colour codes. For example, let's have a look. RGB colours are often represented in hex pairs for the R, the G and the B. 8 bits for each of those colours gives you 2 to the power of 8 combinations for each of the R, G and B. 256 variations of each. That's actually quite a lot of colour for each of these. So 255 in decimal, you can go from 0 to 255, or hash just to indicate that it's hex, FF. Here's an example, again using base 10. You've got your hundreds, tens and units. So 124 is 100, 100, 2 tens and 4 units. In hex, 124 is represented differently because you have the base here of 16, and then again you use the power of 0, 1, 2, 3, etc. So in order to make 124, you need 7 sixes, which is 112, and then a further 12, which is C. 0 to 15 is represented using numbers and letters because there are no other numbers. 0 to 9, and then you need A, B, C, D, E, F. A is 10, B is 11, C is 12, D is 13, E is 14 and F is 15, 15 being the highest number you can write into these areas, just the same as your 0 to 9. So 15 can go in here and 15 can go in here. 15 times 16 plus 15. And that's what sorry, that's 12 because that's a C. So 15 times 16 plus 12. And a final example where I show the whole RGB value. So this is an example where you have all of it set to the highest value, that's the most you can have. So it's all red, all green, and no blue to make yellow. And this is 12 times 16, which is 192. 12 times 16, 192. 12 times 16 to make silver. And in this case of purple, we have some red and some blue, but no green. So we have 8 times 16, 128, nothing for green, and 8 times 16 for blue. And that makes your colour codes. So that's an example of binary, octal, and hex. So hopefully that will help you with whatever you need to do, and hopefully it'll make some sense. So thank you for watching.